Okay, my outstanding friends, we're going to jump right into this. This is all certified stuff. This is all DNA tested, CAT scan, well, not all of it, but enough to show what I will present is based on the facts that things did preserve in this way. Yale also wrote a paper on it, exceptional preservation due to silica-rich oceans, which I'm going to explain all this stuff. And that's exactly what happened here. And they all turned flat as a pancake because they were in a silica-rich ocean. The silica did what's called nucleophilic substitution and invasion and stabilized all of these body parts because this was a hot water flood. Now we're going to start with some of these things under the microscope, but it's all DNA tested in CAT scan. These are DNA tests done back in 2015, early 2015. I had these done, and these were well done. These are PCR DNA tests. These are the top end, and they were excellent quality DNA. It was from the 36-inch tip and the lung. And this is the lung. And it came, I mean, it's just saturated with blood. So we're going to go through all of this stuff, and I'm going to show you, this is the size of a human being, but I have stuff that's off the scale, enormous, as you will see, uno momento. Okay, my friends, this is what I like doing best. This is a hair follicle. Now, I said I have giant things, and I'm not kidding you. This is what a normal hair follicle looks like in a human being. Now, of course, that's the shaft and the hair coming out. This is what they call sebaceous gland, all right, and it's attaches to the side. It's a slippery thing. And this is the muscle, and these are the blood vein and artery. And, of course, there's the little bulb. Now, this is also a hair follicle. This right here is the sebaceous gland. All right, it's slid down to more down to where the bulb is. But normally it would have been up here farther, and the hair shaft has broken off here. Now, right there is where the pili erector muscle would have attached right there. That lets your hair stand up on end. It is a muscle. And it attaches just like any other muscle. It has a center, and it has around fibers in there, and then it pulls back and forth. Now, the fiber comes down here, the hair shaft, and wraps around and emanates from the beginning right here at the bottom, where these two these spots are. Those two spots are the vein and the artery. Now, this is completely transitioned, but it is a hair follicle. Erector pili muscle, sebaceous gland, hair shaft, vein and artery, and that's the bulb. Now, let's talk about the size that we're talking about here. This thing is, I believe, is about 2 inches wide. I have a caliper here. Let's do a little test. I have a caliper, and I have something that would simulate a hair follicle that we can test the sizes and determine how much bigger this creature would have been had it been a human being. This is a good size hair follicle. There's not too many things around today that have anything close to that. All right, I'm going to use this, and this might be a little thicker than a hair follicle, but it's somewhere in that right range. And you see how it tapers off from being thicker and tapers up here. Now, this is a caliper. I have it set at 0 right now. I'm going to hit the 0. There it is. Okay, so we're at 0. Now, I'm going to see how thick it is up here at the top. Up there, it's like 0.02 is what the hair itself would be, basically up at that height. Now we come down to where the bulb would be at the bottom, and we're at about 0.06, 0.05, 0.06. All right, let me write that down. Remember, I said what I said, 0.02 and 0.06. Hold on. All right, another shocker du jour, even for me. This I showed you was the hair follicle from a giant creature. I don't know what it was, but it was found on my property as well as some other giant creature stuff. Now, originally I thought this was going to be, whoa, 500 times bigger than a normal human. Well, I started to do a little calculations, and it ends up, all right, a normal human hair is approximately 0.02 inches, like 2/100ths of an inch, apparently, on the hair. That's what I came up with. And 0.06 inches on the ball. Okay, so up here it's 0.02 where the shaft comes out. Down here it's 0.06. Now, on my giant, this one here, it's 0.25 up here of an inch, so it's a quarter of an inch. And down here it's 2.03 inches. Now, when I figured this out, it's approximately 33.8 times bigger. So this hair would be about 33.8 times bigger than a normal human hair. All right, so let's go with 33 times bigger than a normal hair. Well, guess what? I went back and measured my fingerprints and the giant fingertip, and that is almost exactly the same. The dimensions, it's 36 times bigger. This is 33.8 times bigger. This hair probably came off of this giant. Let me show you the fingertip, which is 36 inches long, and my fingertip is about an inch. So we're talking 30-ish, 36, 35 times bigger, and this is 33 times bigger than us. And so it would equate to about a person around 200 feet tall. Now let me show you the fingerprints. So you've seen the hair follicle. This is approximately 33 times bigger than a human. Now let's take a look at the fingertip. All right, now once again, this was on my property. I did sell this property, and that fingertip is with that property. Now, I'm always going to show this. Is going to keep coming back. I am off the web for a while. Now, this is a fingernail. All right, look at this very carefully. Take your time. Don't jump to any conclusions. All right, it's a gigantic rock. It's 3 feet long from the back, at the very tip back here, to around the front to the tip. This is exactly flawless, this fingernail. And this was flawless. It was completely intact. I had to break this piece off to get inside to get some blood out of here. Now take your time. Look at that curve there of the fingernail. 36 inches from here to here. Now, I measured mine, and they're an inch, maybe a little more than an inch from the front to the back. And this is where the blood and the artery and the vein come in. And this little round spot here is a pad that goes between bones so they don't scrub on each other. Now, remember this. Perfect. I mean, it really was well cared for, to be perfectly honest with you. And when I hit this with a big heavy-duty hammer, it broke right off like a scab. And I can show you why, because it is grip skin. Grip skin is like a complete layer that surrounds all of your fingertips and your toes and the palms of your hand, and it peels right off. Now let me show you what the grip skin looks like. And it still has the fingerprints on it. Your fingerprints start very, very close to your fingernail. They start right up next to it, and that's what happened here too. All right, according to my calculations, that fingertip is about 35 times bigger than a human fingertip, which would bring it to about somewhere around 200 feet tall, which basically is what the hair follicle would be from somebody somewhere around 200 feet tall if it was a human. I know this was because I got inside there and got DNA, and I showed the test. I know I did. And here's the test about the DNA from this 36-inch tip was Homo sapien, mitochondrial B and D loop region. And here it says excellent quality sequence obtained from the 36-inch tip and the lung. And here's the lung. Now the hand was more transitioned into a mud fossil, but it was still good quality. It wasn't like this was excellent. He said it was just like basically like raw blood. And it was. Once you put a little moisture into it, it rehydrates. It just turns just like raw blood. I've shown this so many times. And these are all the different things they did to it. This is a PCR test, which is top end stuff. And this was back in 6 of 2015. I had the test done, and everything was done and finished by 9 of 2015, by September 2015. It was completely done. But before that, I had everything. Everything was done. Finally, I just decided, well, I go ahead and pay the money to get the test done to prove it. But I also had the CAT scans done. Jesse Garant and Associates did the CAT scans. I'll show those in a minute. But not, of course, of this. This thing's 36 inches. I mean, it weighs 500 pounds at least. Now, that was that fingertip. Now, here's the skin that I broke off. Remember I told you I broke off a chunk? Here it is right there. This fit right up. The fingernail is over here. This is how close your fingerprints start up to next to your fingernail. It's right up here. And this, I mean, the thing's gigantic. These are the sweat pores. You see it? These are the 2 sweat pores right here in this finger. My thumb is the width of one of these fingerprint ridges. It's just like you have. Now this peels right off, which is what happened. When I whacked it, it just popped right off. And underneath is just saturated with blood. Blood in the fingertips, toes, lungs, hearts, saturated with blood. And the blood is really the means of preservative, because it has all the transition metals, and the transition metals do what's called nucleophilic substitution. They're charged particles, and they stabilize these things that normally would not stay stabilized. But in the silica-rich environment, boiling waters and so forth, which was exactly what happened during this event. It was a worldwide silica-rich saturation of the oceans. And everybody talked about this global flood, and that's what it was. And Venus almost hit Earth. This was also well recorded. All this is the results of that. Now, remember I talked about the grip skin? Look at this. This is another one I have here. This was also DNA tested. And this has fingertips and knuckles and all that stuff, which I did have CAT scan by Jesse Garant and Associates, probably the best place in the world. They have 2 places, and they do everything, top to bottom. Absolute fabulous people to work with. They did 7 CAT scans for me. And they were so interested in this, they did it at no charge. And I could never thank them enough. And I'll show you a couple of CAT scans in a minute. This is the grip skin. You see that silvery stuff? Let me scooch in there a little bit. You see that silvery looking stuff? It's peeling off. That's the grip skin. It's meant to peel off. That's what it's built there for. It's like a glove on your hand so that you can do work. And it peels right off. That is the tendon. This is a left hand. Lay your left hand back. You got the same thing going right there. That's where your thumb is, right here. That's the pad around the thumb. This is the cleave in between the 2 pads as they roll together. This is the big bumper here. And the little finger runs off this way. And this is only up to about here. This isn't even the whole palm. And of course the thumb is gone, and all the fingers basically are gone. So it's somewhere down around here. And again, I'll show you the CAT scans, because I found the fingertips are there and everything else. Now this one here is only about 3 feet wide, 4 feet wide, somewhere around there. I can't remember, but I have it categorized as a 36-inch wide hand. So let's go with 36 inches, 3 feet wide. And the fingertip, I had CAT scan, one of them. All right, now this is the CAT scan that Jesse Garant and Associates did for me. And the fingertip is here, facing that direction. This is the bone. This black and this white. You see, why are there 2 different colors like that? They're almost identical structure. You see it with a little center core there? You see that with a little center core there? Why is one of them black and one of them white? All right, the reason is, this is with a vein blood, and that's FeO2. Fe2, which is 2 oxygens. This is the red blood, which is artery blood, and that would be Fe2O3. Now, the extra, for some reason, it makes it very fluidy, and the red blood runs right out. The black has vein valves. There's veins. Black is the veins, red is the arteries. So the veins have valves, so they stop. That way there, it can't go back when it's used. It's just got only one direction, and that goes back through your system to get recharged. Now, this is the bone. Now, you said, Roger, why is that bone not in the center? Maybe it was laying this way, and the bone drifted down in this wet mess. I said, no, it was laying flat like this. This is the flat spot. So it was like this. So why would the bone be over here? That is a thumb. I'm not kidding, it's a thumb. And it's a right-hand thumb. If you take your finger and bend it back like that, you got a lump sticking over this way, just like this one does. And out of here, the bone is down here. See, the bone is flat here, and the lump sticks off the top. Just like you got the same thing you got. Now, that was one of the CAT scans. And let's see. This is the 3D. You don't get much on the 3D. You see the 3D here? 3D, the other one was 2D. 2D means you're looking at the surface, and they take it from every single different direction all over the place. And then when they composite it together, you get a really good look. And I'll show you in a second, and you'll see. This is inside the scan through, which this really turned into almost mud. But you can see where the bone was. Remember, the bone was offset. There's the bone. And really what you're looking at is more the membrane. Membranes did not transition the way the flesh and the rest of the stuff did. Membranes stick out. Now, this is the fingernail. Now, remember, this is 2D, so they're taking pictures from every different angle and composite together. That right there, as you can just barely see, that's where the fingernail was. All right. That's the same one we were looking at the end, and the bone is in there, but that's where the fingernail was, the bed of the fingernail. And you saw the grip skin peeling off. You see it peeling right off there. That's just the way it works. It's not supposed to be stuck too hard, and it's thick and it's tough. And that's what it is right there. That's the grip skin, keratinized cells. And you can't get any blood out of there, so you got to go below, which I did, and I got just a ton of blood out of there. The fingertips and toes and hearts and lungs and livers, it's saturated with blood. And again, I think I already mentioned the reason that the blood is so preservative is it has all these transition metals which invade the chemistry that's there. Normally they drop things off and leave and come back with something else. But this time, you're dead. They attach. They find something to bond with and become stable. And they're saturated with blood, and the blood is what preserves the chemistry so exquisitely. I mean, it can be absolutely flawless. As you can see, like this is a piece of meat, and it was in a condition where there was enough blood and enough silicates and enough watery conditions, and it soaked a long time enough in the heat that it preserved exquisitely. The fascia, connective tissue, muscle fibers, the sarcomeres, the whole thing. Now, and I have so much stuff here that we're going to be going through in a minute. I have a ton of stuff. I mean, I have more stuff than anybody in the entire world related to mud fossils, because I discovered them, and I've been researching them for 15 years, and I'm going to tell you every little detail about these. And I have all the chemistry, I have all the tests, I have the DNA, I have the CAT scans, I have everything. So there's nothing here that's missing. And I'm going to show you giant creatures. You want to see a lung that preserved really well? Look at this. A friend of mine, Gary Evans, over in England, went out and he saw this thing in a salt flat, and he saw that and he thought, boy, that's kind of interesting. So he brought it home, and he broke it open. You see, this looks just like rock. You see, it? Just like some kind of rock, a big dirty old rock. Well, inside is all this. And he said, that's interesting. All right, so he's seeing this stuff and he's thinking, that is very interesting. So then he goes a little deeper into this and he gets it nice and wet and he sees it's a lung. And of that there is no question. There's no doctor even that could possibly dispute this. These are the main, and this is a lung too. All right, this one just completely washed out. But it has the same tubing and everything in there. They're all over the place. I have them here coming out of my ears. Now, it depends on the conditions. The conditions that it's found in depend on what you will end up with as the result. This, everything here washed out, and all we have is the fabric. For some reason, the fabric was preserved. And all of the blood and all of the other stuff left. But all the cavities are here. Now here you can see this was really compacted in the wet mud. So this is why it's black here. This is the exchange of gases. This is where you're going to get your vein blood is going to be somehow turning into the red blood. See the red blood here? It's real red. And this is real black. All I can say is that that's the way it works. Your vein blood is being exchanged for your oxygen blood or something. You know, I'm not sure exactly. I know the blood passes through there, and it gets pumped in with oxygen. So this is coming. Let's say this is coming in saying, I need oxygen, and this is okay. We got some over here, all this red stuff, and you come out with red blood. All right, you see this? This is Gary's lung. Remember, we got black and we got red, and we got some serious plumbing right there. Well, guess what? Here is the anatomical. This is your black blood. It's showing up as blue, but the red is the red blood. Now, you're going to have two different areas where they're going to be saturated with the black and saturated with the red, and then they intertwine and mix and so forth. Now it looks like, I'm not sure whether this one side of the lung does something different than the other side. This is more, you get more red blood transferred. But what I saw from Gary's lung, it looked like a single lobe. All right, I would go with a single lobe. And there's the black side, and the other side is the red. Where was it? See, that's the black side, and this is the red side. And I would go with that being one lobe, one lung. All right, and probably just had two lungs, I would imagine, like most creatures. And that's what happened there, is that's the transfer of the black to the red, or the red into the black, so they continue on and be oxygenated. And that's just exactly what we're showing here, the red and the black. No difference. All right, so let's get down to business. This is the basic concept of a lung. You breathe oxygen in, that oxygen mixes with the vein of blood surrounding the alveoli. You'll see this in a minute. And then you exhale out, you know, your carbon dioxide, basically. Now, so you're breathing in, you're breathing out, you're breathing in, you're breathing out. The oxygen turns into red blood. The blue blood comes in as the vein blood, and it wants to absorb the red blood, as we saw before in the exchange of the lungs here. All right, these are all exchanging, and these are all these little alveoli. You see these little tiny holes? Those are all the alveoli, which are basically these, only they're even finer than that. These are more like these. Then you get way, way, way down inside there, and you get to these little tiny ones. All right, that's where all of the oxygen exchange happens. All right, so here's your biology lesson. You're breathing air, so you're inhaling air. It comes down through these bronchioles. Now these are muscle bands that hold these tubes in position and let them rock around and move as you do all kinds of whatever you do. Now this is a pulmonary vein. All right, now I think they got these backwards. The red should be the artery, and the blue should be the vein. That's the way I would take it. Red is always artery, not vein. So I think this is backwards. That's all right. You get the point. One of them feeds it, and one of them goes back into the bloodstream. Now, what do we have going on here? Here's the air coming down. It comes down into all of these little balls, which are basically these things. And then they go through all these little tiny alveoli ball holes everywhere through the sac, the whole sac, and there's two of them. Now, what else do we have as far as the lung goes? They got the balls, but the balls have to get big and small and all that. So they have elastic fibers. You see the elastic fibers that surround every ball. And every ball has to be able to bring in the vein blood to absorb the oxygen and come out through the red blood side. All right. Now, they're going in and out of all these holes all through the whole lung system. So it's an air sac, the whole air sac. And they call these holes alveoli. And I think this is backwards. But anyway, there's a bunch of tubing that goes in, and these capillaries are the tiniest little places that surround the blood vessel, the alveoli. And they have like rubber, they're like little rubber bags. They open and they move around a little bit. Think about it that way. All right, this is the lungs. This is what they look like. This is the structure. See all these little tubules? Well, watch this. If they eroded and left those tubules, that is exactly what you would have is this. Now, Mayan did not erode in that particular manner. Mayan kept the skeletal structure and the tubing washed away, it looks to me like. Because I can see all the little holes, but I don't see any really structural tubing. It depends on the chemistry it was in. And they can turn into opals. They can turn into solid glass. They can turn into a whole batch of things. Now I want to show you something about transition metals. This is what's in our blood. You see all these charged 3, 2, 4, 5, 6 plus. All these are different metals. And they are in the transition metal area here. And this is what your blood is made out of, which is almost 100% made of these, primarily made out of iron, because that's what carries the oxygen. All the rest carry trace minerals and everything with these charges. They're called ligands. So they collect around the metal core. So titanium collects a bunch of different particles around it, which are charged up based on its charge, and they go through the body system and they drop off where they're needed. Now, when you die, they're still moving and they're still in the blood. What do they do then? Well, they're going to get attracted to something, and if they get attracted to the right thing in the right conditions, you'll see certain tissues will be green, other tissues will be blue, other ones will be yellow, and it depends on the chemistry of that tissue. Can I prove that? Yes, I absolutely can. All right, here's the thing to take away from this. These different colors correspond to different charges on different atomic transition metals. All right, and that's why they have different colors. They radiate different colors. That's not what you have to worry about. What you want to think about is these become stable. After you die, they attach to something and they become stable. Normally they're just going to float around and drift around, and something will become blue and something will become green and red, and they'll have all kind of different, like this. It's just all kind of crazy stuff in there. But sometimes they collect exactly because of the water flow and all that stuff. And I will show you that in a heart. Because this is what happens. The metal ion collects a bunch of stuff around it and carries it through the bloodstream, drops it off. That's why it has these charges. Picks something else up, comes back and gets recycled through the liver, the heart, the kidneys, the lungs, all that stuff. When you die, it's still going around. It's still out there. It's still there. It still has these charges on it. Now it's looking for something to interact with. And at this point, it's not going to dump something off. It's going to say, hey, the guy's dead. I want to become stable. Will you stabilize with me? And it says, well, I am a heartstring. Have you got any blue? And he says, yes, I have blue. So, all right, come on down. And the blue comes down and it bonds with the heartstring. Now, it only happens in certain cases, very obviously, when you see opals. Let me show you the opal. See, I'm just disregard that. This is going to be forever. All right, you see this? This is a cross section of a heart. That's a pacemaker or something. Now, what do we have here? We have heartstrings. We have the fibrous material that makes the heart sort of flop around, and you have the heavy-duty muscle banding around the outside. It's actually like one big round strap, and it wraps around like this, and that type of thing. Now, you have your aorta and all your plumbing up at the top, and your valves here. All right, now, I have a heart here that's completely turned crystal, but the one I want you to see is the one that's turned opal. Now don't forget, this is different tissue. It doesn't look all that different. You can see this is whitish, this is a little yellower, this is a little browner, this is a little bit different. And, you know, a little bit different here and there, but no big deal. Well, guess what happens when these transition metals come and say, I want to attach to you? Then you can really see the difference. All right, same deal. This is a heart. Remember I showed you the heartstrings and all that stuff, and the ventricle walls and the aorta and all the plumbing and the tubing coming in and all this different stuff. There's a certain tissue, and it has a certain molecular chemistry built into it that says, I want the blue. And whatever the blue is, I don't know. And it becomes stable. Now, this is because of Australia. These are what's called Yoa nut opals, and they are organs. Basically, they're all biological things. I've looked at them, and they're virtually all that I can tell are organs or clam shells or eyeballs or all kinds of, I mean, I got all kinds of stuff that I've seen that are they're body parts or there's some kind of biology. Because this, it only happens because of the transition metals flowing through, I believe. And as far as I'm concerned, Australia is like one gigantic scab, just one big red spot. Now, this was laying down this way. And I know this because this is pretty much plasma blood with very little transition metals in it. This is dense with transition metals, which are up here. They're heavy. Specific gravity says further up the periodic chart, the heavier they are, the more gravitational influence. So if it's this way, the metals are going to fall to the bottom. The plasma is going to rise to the top. We've all seen that in separation of layers of different things, oils and water and that type of thing. Now, there's no denying what this is. It's just undeniable. And the same thing with the one I have here. This right here. This is a crystal heart, and that's the aorta right there. There's a little taste of blood right there. That's, well, here, let me show you once again. All right, this is basically right up in that area somewhere, however it points. This is this big heavy-duty band. All right, this is not cut. This is complete. And this over here is some more plumbing. See, this is like this one this way, this one this way. But this is over like this, and this is like that. And then you get down into here where the valves start to take over. And this is the ventricle wall, you see it? And that's a heart. Now I have another one here that I cut in half. You see this one? that's all heartstrings. Fibrous stuff. The collagens do not crystallize the way the rest of the body parts do. whenever you have membranes, and these are basically exactly the same as membranes, they are rubbery substances, just like a membrane is. So it's made out of basically the same materials, collagens, keratins, and they're rubbery, and they do not turn into the crystal like the gelatinous stuff of the body. And I can show you that in Mitchell Hedges. You want to see something? What do you see this? Don't forget, what we're looking at now is biology that is turned hard, and that was a heart that pumped blood at one time, and that's the blood that was somewhere in there or puddled into there and then invaded. It's called nucleophilic invasion and substitution. It invades and pushes the other stuff out and says, hey, this guy likes me more than you, so just get lost, and I'm going to take over anybody that's got this chemistry. And sure enough, there it is. All right, listen to this. This is a scan of a brain, and all of these are nerve fibers, and these are the coatings that coat the nerve fibers. And they show up in different colors because they are different chemistry. That's why they're different colors. Now, this is the Mitchell Hedges skull. This was of a patient brain scan. This is a crystal skull found in 1924, Mitchell Hedges, and it's been controversial ever since, and they claim it is not authentic, that it's modern reproduction of whatever. Which she found in 1924. All right, so that's 100 years ago. Now, here's the deal. You see all of these fibers? You see all these fibers running through here? They're identical. Identical. And I know why. Because nerve fibers, the coatings on them are constructed of a special type of collagen. And it coats every fiber and separates it from its neighbor so that it conducts signals and so forth. That's why you see how fine they are. And when you can see them really up close, cross sections, it's just staggering how many fibers there are. And they all go to certain areas. So your brain, I think this is a cerebellum. Yeah, I believe so. Anyway, you got your cerebrum, your cerebellum, you got your visual cortex, you got your medulla oblongata, you got all kind of stuff. And they all control a certain thing. Some of them control nervous systems and the temperature and the autonomic system where everything just runs by itself. Now, they say this is a fake. Now, pay a little attention to this. These are inside, deep inside. These are not scratched on the surface. And they are literally identical. Literally identical. Literally identical. Now, what is not identical? What's this big space here? This has a big bulb back here. We got nothing, no big bulb. Well, guess what? This was on its face. And I can show this in a number of ways. And when it did, the bulb drifted forward and this filled up with fluids and became just clear, watery, see-through. Now, so the bulb moves forward. Why would I say it was on its face? You see this? This is the lip. It's twisted back. Take your time and look at that. Anybody that was a forensic guy and misses this, it's just incredible. And I've dealt with a bunch of them, and it is just astounding, the incompetence. This is the lip twisted back. This is the nose twisted back. These are all the fibers that are seen in a normal human skull. Now, the teeth are so exceptional. When I first saw this, immediately I said, there's no way, absolutely no way. But, you know, my nature is to look at every detail and then make a decision. But I remember saying to myself, who would ever believe this? Then I realized that crystal, specifically quartz crystals, they form in blocky, like they have little angular things, and I think it must have something to do with creating the angular flat pattern of the teeth somehow, whatever. But I mean, they are flawless. Look at that. That is just stunning. And my understanding is the mandible to jaw here comes right off, just like a normal human jaw, which ours are held together by tendons and muscles. That's all. There's no pins and hinges or anything. They're held together by muscles and tendons. Now, if you could say that somebody did this, I would like to know how, and I'd like to see somebody do it, because I don't think you can. That's because this was in a quartz crystal situation where it has something to do with the way the water flowed and the chemistry, the pH, the temperature, the whatever. And everything was evacuated except silicon dioxide, SiO2. So this had to puddle down where there was some really dense silicon. I would say, like at the bottom of a deep well or something. And the silicon settles to the bottom and just invaded whatever was there. I don't know. All I can say is that, in my mind, is 100% certainty that was alive at one point in time. And this was from the silica-rich oceans. And silica is very dense. This is much heavier. Silica is much heavier than water. So when it's all that density of silicon, and if it filled down like I say, maybe a deep, deep well, and this guy was deep, deep down in the well, that's possible. Something like that could have supersaturated the waters down at the bottom of the well where this guy's head was. That's all I can think of. His head's laying like this in the well, and it's supersaturated. He's at the bottom, obviously, because his face is at the bottom. Now, I have something here that's very exceptional. This is exceptional. I mean, obviously. I mean, come on. But I also, I think I showed, well, I know I showed you the heart, a silicon heart, and, you know, it's nothing as spectacular as this, but if it was cut and cleaned up nice, you'd be able to see all the structure of the heart, the aorta, and all that stuff. Now, I have one here. Hold on, I'm going to show you this along. All right, I believe I told you it's the blood, the transition metals in the blood, which are the stabilizers of this biology. Once it was boiled and everything was pretty much flushed out of it, except the blood where the fascia protected it. Some of it didn't protect it. You see how that's protected with fascia? This is this one right here. All right, and that is actually literally, I can scratch that and put a little water on there and the blood will come out. I drilled a hole in here and deep inside to get some blood out of there. And you don't get it from the surface. You drill a hole and you go down inside and you take out some blood, literally, and they're saturated with blood. This one here, all of this coating, that's called a fascia, plural. And it's the coating on the lung, which is like right here. You see this? This stuff is the coating on the lung, which is this. All right, then under that coating is the alveoli, which is this one here. It's this stuff. All right, so here we got the pleural on the outside. This fabric, it's a rubber bag, and it protects your lung from invasion. And it's a rubber bag. That's what it is, and it's very dense and thick. And I will show you that because I have one that's halfway worn off. This one is completely missing. So this one is just like brand new. That's the fabric, and it's very, very, very good shape. This one, all of that fabric is gone. 100% is gone. We're down here. All right. This one, we're out here. We're out looking into this fabric. That's the fabric. And then inside is this, which is this, which is this. Now, what is this? You see all these little red dots? Blood came out of there. Little tiny little blobs of blood came out. And this is the little tab all lungs have on them. Like, see this red spot here? That's the same as this, only this one here is stripped down. This one here still has pleura coating it, so you really can't see it as spectacular as it is. This is a latch, a literal latch, and that is too. And they are on all lungs have them. Even the ones like on chipmunks and whatever. This is a lung too. And that's that latch. We'll be looking at this in the microscope. Every single one of them has it. And that's where the air entered in here. And every one of these is a little alveoli, those little alveoli holes. All right, we got a lot of looking to do, because I mean, I'm as deep as you can get into this, as deep as you can get in. And these things can be small, little tiny lungs like this, and they can be very, very large. That's a lake. I'm not sure where that is, but all these different colors are because of different transition metals. And you see how you got these here from something collected in these, and they're different colors in different areas, blues and greens and reds and so forth. And this is not the only place that there's not a ton of these, I don't think, but there's enough of them. Well, here's another one area. You see this? Now what's going on here? I don't know. That looks like one of those wacky artist guys just throw blobs on stuff. But well, let me put it this way. Every different color is a different chemistry. What is a different chemistry? It means a different transition metal. It means a different enzyme. It means a different biology. It means different molecules. It means different interaction. Now, how can all this stuff in one little area like this? I don't know. It could very well be a lung that is just saturated with all kinds of transition metals, because they do that. They separate off into their own little vessels. Let me see. Let me show you something. Look at this thing. Now, I showed you, well, way down here is where those little little alveoli are. This is the pleura on the outside. So this, right here, is this. Right here. Inside this is the stuff I showed you before that was leaking blood. All that's gone. And the little bits of drops of blood were leaking out. Alright, where'd it go? You see this one here? That's where the little blood drops leaked out. And these are all the alveoli holes. And here's what the blood was. It came out, these little tiny blobs. You know, not a ton of them, but there was enough. I mean, you see all these little red spots? Now, what happened here, I believe, was this was in the ground this way. And this was sticking out of the ground, and the blood, literally the blood ran down into here, which was in the mud. And the mud, when you're in the right conditions in the mud, the blood will just stay there. It'll just puddle there, and it won't go anywhere. Because mud is basically flesh. So it just stayed in there. So this, I think, was sticking out of the ground. And it all washed down into there, rain and all that stuff, and just the natural gravity. All right, so, and it collected down here. And then when it came out of the ground, that's what you got. And nothing here was very deep. It was all right on the surface. Now, remember all of this here. We got all these little things going on, the little tubes inside the lung, and this one here has deteriorated in such a way that it left the tubes. I don't know why. Usually the tubes, well, I don't know, this is what I find, usually looking like something like this. This is an anomaly to me, and I like anomalies. Now, can we use this to our advantage at all? Well, maybe. But you see all these little holes, and you see the little red blood and so forth. This is an area where there was red blood, and I think it's a lung. I'm almost absolutely certain it's a lung. Now, that, as I just showed you, literally is this. All right, there's virtually no difference. Now, what does that mean? In every one of these little pockety areas, there's going to be blood, and blood turns into all those different colors. As I showed you transition metals, I know I showed you this. All of these are different transition metals, and they start to form what they call crystal silicates. Silicate means the silicon dioxide bonds with these charged metals, and they start to grow crystals. And they grow them according to their colors and according to certain shapes and hexagon and so forth. You know, everybody knows what a crystal looks like. I mean, and they are all different colors, because you see them all ruby and this and emeralds and all these different colors. Well, that's because they're different metals attached to different silicates primarily. A diamond is a different story. That is not a silicate. That's a little above in the carbon. They're on the top of each other. Silica is up here, carbon's right down below. So carbon is where diamonds come from. That's all you got to know. At any rate, this is where you get all the different colored crystals. Okay, my friends, prepare for this. I have shown you all of these things, but now I'm just going to roll it right down the road. This is a lung. Inside is all these tubules, which I have shown you before. This also is a lung, and it is eroded in a different manner, and this is the back, and it still has some bone bits in here. You see those are bones. This is extremely unusual to find bones in with mud fossils. Normally, and the reason it is because it laid flat in, I believe, the black cap. In other words, there's normally a red bed, gray clay, and a black cap. I think this was on top of everything on top of the black cap, and that's what preserved the bone. The bones normally don't preserve. The only other one I have that has any bone at all is this, and the only bone that's in there is that right there, that little white spot. That's the only one. Otherwise, they could completely transition. It has to be in a certain way, in a certain depth, and there's so much differentiation to these things. Because this is a lung, and that's where the plumbing comes in the back, and it turned all to silicates. And the reason it turned to silicates is because there's a big hole in there, and it was in some chemistry that allowed that to fill with the silicates. Don't forget now, this was a lot of silicon here, a lot of silicon. In some places it was much more than other places. This is a lung too, and I think this guy got poked right through there, right through his lung right there. You see that? That's not supposed to be like that. It's supposed to be kind of smooth like this. And that one spot is kind of, like a, it almost looks like a big round spear shot or something. Anyway, but these are all big ones, little ones, and I showed you the hair follicle. This would be from about a 200-foot tall guy. That's what I kind of end up with. But I have them all different sizes. Here's another lung. Remember I showed you this one with the silicon in here? There's another lung. You say, oh, that's not a lung. Yes, it is. And that's where the silicon was. That's where the hole is back there on this one. I think this guy was a smoker. You saw this black-looking, sooty-looking stuff at the bottom? But anyway, that's lungs. I got them coming out of my ears. I got ears coming out of lungs. Look at this one. I showed you this one. Well, this one here is just eroded on its surface. All right. And this was laying in the black cap, I believe. And that's why this is so black and nasty back here. But there are bits of bone. And that's what preserved it. And then everything ran off and ran off and ran off. And you ended up with this. This is nothing more than flesh. It's eroded away. And these are the alveoli. And of course in the back is his, the back of his ribs or his backbone or whatever is back there. Same thing you have in your back. And this is a side view of his lungs. That's looking sideways down here. And you can see there's cavities. I'll try to do something in the microscope with this one. I have other ones we want to look at in the microscope too. There was something I wanted to show you. Hold on. Yeah, so don't forget now. This is like virtually brand new. You could almost transplant that lung. It's perfect. The pleura is completely coating it in very, very good condition. And this one is completely stripped, nothing, all the way down to the pleura. I mean the alveoli. The pleura is completely gone. Look at this one. This one's half and half. This side here is like that. You see it? These are all the little alveoli. And you can see them in the microscope. You can see all these little tiny holes. That's the alveoli, and the pleura has pushed off. And you see how dense and thick that pleura is? It pushed off to the side. And again, flat like Z pancake. And it died in the Great Flood. And they all did. All my stuff did, as far as I can determine. It's almost all flat on one side, totally flat, and the other side is just flawlessly perfect. The lung is the same way. That lung right there. And now don't forget, DNA tested and CAT scanned. And anybody can test it. All you got to do is scrape this off good, drill a hole down inside, get some bloody, dusty stuff out of there, and send it off to get tested. I'm not going to do it again. I already did it. Flat like a Z pancake, and it's got even where the heart would sit right here. So the guy had to be completely assembled and died flat on his back like this, with his heart still attached back here in this cavity, which is, it's a left human lung. And it is human, came back human, DNA tested. So the heart would have been sitting there. So he must have died altogether. And when they boiled and settled, and all of the minerals and silicates and salts and all that just dissolved everything, turned all the fleshy stuff into what was called the red bed. And the red bed was nothing more than boiled flesh. And then the gray clay came after that, which is bones and tendons, you know, the little tougher stuff, organs and stuff like that. And then a black cap came on top of that, and then that was the whole event. That's the Triassic. Red bed, gray clay, black cap. Now guess what? Not only do I have all this stuff from the Triassic, I actually have a human footprint in Triassic rock. If I can find it. Here it is right here. You see that? This is the red bed. Now this is actually the gray clay. That is supposed to be above the red bed. What happened, this was wet and soft. At the same time the guy stepped on the gray clay, it pushed this down through the red bed. And now they're equal to at the same height. And you can see the gray clay is down below the red bed, not supposed to be. It's supposed to be above. Gray clay comes second, black cap comes third, and this is the black cap. And it sits right on top. That is, well, I might as well show you. And I actually have a foot that's very similar to this. It's a human-ish foot, but I call them no toes. The toes are built in. That's not a shoe. All right, don't forget. Red bed, gray clay, black cap. Red bed, here it is right here. There's the red bed. This is gray clay, which was up here. When he stepped on it, that gray clay right there pushed down through its red bed, which is this red bed. Because that's all the boiled flesh. And it pushed this gray stuff down. You see it? Down through. It shouldn't be. It should be on the other side. You see the red is up here? The gray is supposed to be this side. This all happened within hours or days. And this is as close. These are the balls of the guy's foot. He was running, his heel hit here first, and went here like this and pushed up, creating all of these exact patterns of a foot hitting the ground fast, running to try to save its life. And these little dimples here, I call them stirrups. These little things right here, when he hit, it was wet and it went and sucked them up. So I'm in the gray. This is upside down. This is supposed to be just the opposite. So the Triassic happened like on a weekend. I'm telling you, they got this so far wrong, it's unbelievable. And everything I have came right off the surface of the earth. I didn't dig hardly for anything. I'll tell you, it gets more and more amazing every day. I remember I said pulmonary vein. Veins are supposed to be blue. Arteries are supposed to be red. And I'm looking at this, I'm saying something's wrong here. So I look it up. And they said, yes, the pulmonary veins are often shown in red, and the pulmonary arteries are often shown in blue. However, these are not the correct colors. I'm not kidding you. Okay, my friends, to do this justice, it's going to take literally forever. But we're going to be going through all of the air sacs and different blood vessels and how the blood flows, and I'm going to show you my stuff here. This is nothing more than that right there. All right, and that's the guy's back is where the bones were. And like I say, I think this died on top of the black layer. Anyway, we're going to be going through all this in extreme detail. This is from somebody named Dave Carlson, very nicely done. And it's going to show exactly what happens inside these little alveoli of the lung, these different colors and so forth. And I'm going to try to explain to you all of this stuff. So, but again, it's going to take some time. This is not a 5-minute job. So the next video will be stunning. And we're going to be looking at huge, huge lungs. All right, I showed you these lungs can be pretty good size. Well, that's a pretty good size lung if you ask me. And they do come that size. They do come that size. And if it eroded in a certain way, that's precisely what I would expect to see. These little tubules sticking up and the erosion of the tubules. And again, they erode in all kinds of different ways. Like this one here, just the tubes are left. So we've got a lot of thinking to do to understand really what our true place in the universe is. First of all, if all this stuff is true, and it is, my stuff's DNA tested, some of it's CAT scan and DNA tested and all that, and it's all over the earth. Here's the people standing next to these little pools, and these are going to be lung alveoli that are filled with different bacteria, basically because your lung is loaded with biology. Bacteria thrives in biology. I mean, that's what it is. It is biology. So what we're seeing on Earth is biological processes. All these different colors mean different chemistry. Different chemistry is what the body works on. It's all kinds of different chemistry. And it works on enzymes. Enzymes are the catalysts that make and break things. They make building blocks to build things up, and they make enzymes to break things down. And also the bacteria, of course, to create the ribosomes, which are those products I'm talking about. But in addition to that, there's viruses. And they claim there's 10 times more viruses than there is bacteria. We're talking like 380 trillion viruses in your body right now, and mine, average person, 380 trillion, and 38 trillion bacteria enzymes. But the viruses are not always, they're not necessarily bad for you. The viruses aren't necessarily bad at all for you. They're mostly good for you, because they do basically the same thing the ribosomes do, which is to break down chemistry. And I'm sure these viruses kill other invading viruses, because they say, no, we live here, everything's cool, we've been eating good, we've been taking care of each other, you're not coming in here. And it kills invaders. That's a good virus. And the bacteria do the same thing. Now, a virus is the same size as a ribosome. A ribosome is so small, it can go through the blood-brain barrier and all this kind of stuff. All right, and a virus is maybe just a little bit bigger, but I think they can get through the blood-brain barrier. Hold on a second. All right, I think I showed you the little latch that's on all the lungs. That's the latch that was on this lung. I cut this one in half, and you're going to see the blood in there and all these different colored crystals that are basically what you're seeing here. Now, this one has that latch, which they all have, and this is where the air went into this one, into some kind of I don't know what, but all the pleural is gone, and all of these are the alveoli, which are these. And there's that latch. And this one here, there's the latch on this one too. This one died crunched flat like that. Something like that, I don't know. Anyway, and they all have that latch. This one has it too. See it? See that little flap right there? And the ones all the ones I showed you have the same latch, so they all have it, and they all have these alveoli in them. Now, in a pocket like this, all the colors, they say it's from bacteria, and it is basically. A lot of it is bacteria, but the bacteria is because it's working with the transition metals, which are the colors. All right, that's how they move things around in the body. This is from Bristol Myers Squibb. And I believe this is blood, and these are the sacs which have all the colors in them. Basically something similar to what I was showing right here. These are all the sacs. All these colors are little crystals that have just crystallized. Now, I don't know how somebody did this. They must have etched this with acid or something. But I believe this is the webbing. And these are the blood that was in there at one time. They must have sliced it and then etched it or with acids or something. I don't know. I really don't know. People send me these things. I don't know where they came from. But I can tell you what, that's what I would expect to see. Just like when you look at wherever it went to. This right here. You see all these little pocket looking things? And then those are different colored blood cells that turn into different colored seeds. They call them seeds. When the seed starts, it stays the same color. You know, and sometimes they change a little bit, but most of the time they stay, and those little pebbles are all the same colors, which is what you see here, which is what you see here, what you see here, what you see here, and this webbing and all that, and here it is right here. You see them, all these little globby looking things together, and stuff goes through, and this is where the blood goes through. And the blood is all the colors. That's the colors of blood, my friends. That is the colors of blood. You got green and blue and red and pink and yellow and brown and black and, you know, every color you can think of. Now, let me show you a lung that I have here in a microscope. It has all the same colors, and it has the same webbing, only mine, well, I'll show you right now. Here it is right here. It's this one, and I've been soaking it so you'll be able to see. All right, it's cut in half, and this stuff here will be the webbing, and these will be the colors. All right, I'm going to put it in a microscope right now, and you'll be able to look at it and see. If you can see how it's real shiny, and then there's stuff that isn't shiny. That's where the blood is. The shiny part is where these crystals are, and they must have etched it with acids or something. Let me show you. All right, get ready for this. That's the stuff we're talking about. This is the little lung that's in the microscope. Here it is up in the screen here. Now I have to turn the lights off before we'll be able to see it, and then I have to home in on it and turn the scope lights up a little bit. Now you see all the shiny spots? Those are all minerals, and they're reflecting because it's cut very smooth. They are colored though. Let this thing sink in for a minute. I think I went too bright on the lights. You know what? Sometimes you have to have it on an angle to see it. There we go. All right, now on that angle we can see it, so it's not reflective. You see it? You see all those different colors? Let me tune it in here. You see all those different colors? This is identical. It's identical to what we see in that. Now, how this webbing is in here, I don't know. Because I don't know. Now, I'm going to move it over to where, you see now you can see, this is where blood is. All of that brownish looking stuff is where blood is. These are all where all the metals are collected and the shiny stuff. All right, does that make sense to you, my friends? You see all these different very cool colors? Blood is what makes extremely cool colors. And it's smooth except to where the blood was. That's why the brown looking, bland looking stuff is where blood was. So if we tip it so that it doesn't reflect right back at us, we can see all these colors. When it's coming right back at you, you can't see them. Now let's see if we crank this up a little bit. Hold on. I could do this all day long, which I mostly do. You see that? That's the different colors of blood. Isn't that something? All right, so we saw that, which mimics this, which mimics the lung, which mimics the blood, which mimics the silicas. Mostly these are all silicas, and they're metal silicas. They're transition metal silicas. All right, so don't forget, this is just going to go on forever. So we're going to be getting very deep into all of this stuff. Hopefully my network connection will be back sometime next week or this week. This has been a long time. It's been down. Nobody seems to know anything about it. Now, this lung here is about similar to the size of the guy with the 3-foot hand, I would say, which is the small one I have. That's this hand right here. Now, I got so much stuff to go along with this, and I got everything right here in the microscope. We can do a little bit of chemistry, not much. Chemistry is expensive. I don't have the resources to do that stuff, but I can show you, and we can see, we'll be able to see the chemistry. You don't necessarily have to do real chemistry to see the colors and to see the anatomy and all that stuff. It's very, very simple, basically. This is grip skin. This silver stuff is grip skin. Now that could be tested. It's supposedly 50 times more silicon in this than the other parts of the fleshy parts. Now, we also have a lot of silicon because of the Great Flood stirred up all the siliceous ooze from the ocean deep when our atmosphere was wrenched by Venus almost hitting it. And again, this is all recorded. I'm not making up any of this stuff. If anybody paid attention to Velikovsky, which they will now, because I have every single thing that supports every single word he said. There were all the things that they had reported long ago. We always laughed and said they were making up stories to scare kids so they go to sleep and be quiet. No. These things were factual, and then they became so lost in history that they became just, who's ever going to believe that? You'd have to be insane to believe something like that. And I agree. However, I have the evidence. I am not just talking about, oh, it must have been this, or oh, it should have been that. I'm talking about lakes like this that are lungs. I'm talking about gigantic things that are creatures' body parts, and I mean gigantic. My stuff is good size. Look, guy's got a 3-foot long fingertip, one little fingertip, 3 feet long. That's good size. You know, he squished it with his finger. Hey, you. So what do you say about that? And this was all recorded in history. 100% was recorded. And Enoch, who was one of the historical figures, there's no denying he was here. And he said they gave birth to great giants whose size was 3,000 ells. That would equate to over 2 miles tall. And I don't see that as being outside the question. Not whatsoever. Not whatsoever. I mean, my guys are not that gigantic, but some of the things are, I mean, just stunningly enormous. As is Typhon, who runs all the way across North Africa, cited in Apollodorus 1.6.3. Read it. He was attacking the gods. And he is there. There's no question whatsoever. And they changed themselves into animals. And he was attacking a fish, which is right underneath him. He runs all the way across North Africa, and the fish is right below him where he was spitting out this noxious venom. Right across North Africa. And he's on maps from 1375, showing his body run right all the way across, and his throat was cut by Zeus with his great and mighty sword, was what the ancient texts, some of them said it that way. Some of them said he struck him down at a distance with thunderbolts and an adamantine sickle and all this. And then it goes on to talk about throwing Sicily, the island of Sicily, on top of him, or something like that. A whole bunch of stuff after that. After that, it gets a But up to that point, I mean, he's there, and his throat is cut, and he's on the map with his throat cut. And he runs all the way across North Africa, over 1,000 miles. And you think I'm kidding? Look on Google Earth, look at all across North Africa. I'll show you what he looks like. And then if you have to, come back and refer to what he looks like, and you will see. Now, in the next video, we're going to go through all of this stuff in so much detail. It'll bore you, I'm sure, by the time I'm done. But I want this to be fully understood. There's no reason you should now not understand it. I was very, very clear about what I showed you. You see this? This is Typhon right here. This is Typhon's head. His body runs all the way across North Africa. Here he is right here, up close and personal. All right, there's his head, runs all the way back across here. This is all runoff from where his throat is cut. And we're going to look at that closer in a second. This is the fish I talked about below. Take your time, come up here and look at it. This is Google Earth, this is North Africa. This is his body, runs all the way across, and he has actually dragon scales back here on his tail. You can see them very easily. And it goes all the way out to here. And this is his body, and here's his head, spitting out all this noxious stuff onto the fish to try to kill it. Apollodorus 1.6.3 says that he attacked the gods. They changed themselves into animals to try to hide, and that looks like an animal, and he squirted as that noxious stuff on. And here's what he looks like up close. This is all the stuff he spit down at the fish. And there's his red flaring eye, exactly what it says in Apollodorus, all that fluffy stuff coming down. This is his throat. These are all dragon scales. You see them? They're all dragon scales running all the way down his throat. And right up here is his head. All right, this is his nose. And they said he was all, you know, unkempt and hair streaming and his red flared eye. That's exactly what they say. Now, this running all the way down here is his throat. This is nothing. Down here is just the runoff of his decaying body. You see, it's just effluent, they call it. It's red, or, well, it's not even necessarily red. It's just sort of fluids that run out of a decaying body. If you, and I have coroner's pictures showing that. It's kind of gross, but anyway, these are the scales, and that's where it stops. Down here is just you know, runoff from a decaying dragon. You know, they're all over the place. Now, I'm not kidding. Now, here's what he looks like outlined. All right, this is all the spit he spit down on the fish. Here's his red flared eye. And here he is. It's all flashy and fluty and all stuff flashing down here. All of this is exactly what you see in the parades in China and places like that. They have all that fluty stuff, and they show the dragons coming down and they have all that stuff on their sides. And this right here is where his throat runs, right down here. And this is the armor plating for his throat. And this is nothing, it's just runoff. All right, and there he is. And here he is in the desert, unhighlighted. All right, there's that throat. Running all the way down until it was cut. A little ways further, it was cut with a great and mighty sword. And this is all the spit he was spitting down at the fish, which is just below him. All right, and here's the fish. Here's the fish right there. I believe that's his eye. Now this, I don't know what this is. I believe this is his eye, and these are the scales. They run this way, so he's going that way. This is the tail. And that's a fin of the fish. Now, it said in Apollodorus that they changed themselves into animals to try to hide from Typhon, who was dispatched by Gaia to kill the gods. And he was big enough to do it, except Zeus. Zeus killed Typhon. And Typhon was killed right here. His throat was cut right over here. with Zeus's great and mighty sword. That's where the red blood runs out. This is just leakage from the dead body, but this is where his throat was cut. And I'm disconnected from the web, so I can't get to Google, and it's going to be a while. It's been almost a week now, so we'll find out what happens. Something crazy is going on, but anyway, you can see him. You can come up here and find him. It's there. There's no question. It's there. Okay, my friends, battles in the heavens appears very accurate to me. And these creatures being this big, I can't account for it, how they existed on Earth. I have no clue. I have to assume they came from the heavens. This thing's over 1,200 miles long. And he's only one of many. Quetzalcoatl was real. Scorbzilla is real. And they're all over the place. So we just have to deal with that. Was what they talked about in these ancient texts was all reality. And these lungs, I mean, look at that. That's not somebody building these little houses. I can almost guarantee you if this was looked at, they would know exactly what it was, and it's a lung. All I can say is it's time to wake up and smell the tea or coffee, whatever you prefer. These are just not rocks. That's just not a piece of dirt. When Gary opened that up, it was a lung. There's no question it's a lung. Zero. Now, this is what you would call exceptional preservation. However, it has to stay in that wet, muddy condition, or when it's invaded in salt flats like this. See, here's the key. As I said before 100,000 times, everything depends on where you find this. I showed you a heart that's turned into an opal. I showed you one that turns into a crystal. I could show other ones that turn into mud, literally mud. And that's just like this rock right here. This is a bone. That's the head of a bone. That was calcium at one time. All right, and this was cartilage. But a nucleophilic invasion and substitution says, we're coming in here, everybody get the hell out of there, and it takes over and invades. Now this one little tiny spot right there still has bone. I'm not kidding you. I don't know why it got stuck right there, that one spot. But at any rate, and these things will bleed. The blood will come out of these. Some of these, and I mean excessive amounts of blood. I had a friend, Phil Harris. Unfortunately, Phil passed away. But he found a heart. When he popped it open, he saw this red. Well, let me just show you. All right, we're going to get back to this in a minute. But this is what a heart looks like. These are the valves, and there's going to be a red side. There's going to be a dark side, which is the vein blood. And then there's going to be like a yellowish one. And that's all the plumbing on top of the valves. So you can see them separately. See, this is the plumbing on top of these. And one of them is going to be real red, and the other ones are not going to be quite as red. And the red blood stays red and fluid literally forever. It's just amazing. So here's what happened. Phil goes out, and this was a 15-minute challenge. I'm not kidding you. I swear that's honest truth. I put it to everybody. I said, go out. If you find rocks, within 15 minutes, you should find something that is likely going to have been a body part. Right away, within minutes, he finds this rock. And he walks up and he sees this rock right here. Look at this. This is blood. That's the aorta or wherever it's coming out of. And this is the dark blood. It's not the same blood. And then that's the serum or whatever, the lymph. But everything pumps together through the whole system here. Now, he came up and this was all one piece. I'm going to show you. It came off because it actually separated by itself. He could see this right here, and which is one of the plumbing of the heart. And I think he saw this too. I'm not certain, and he's not here anymore to ask him. But this, he wrapped it like with a hammer or something, and it cracked right along there. Now I'm going to show you the other piece that was on top of here. And it came right apart on that seam. This was soaking wet. The other side was not hard dried, but pretty dry. All right, you see it? right, this was on top of the red spot. All right, and the dark blood is in the middle. And this had, apparently the red blood had settled down below and left a little cavity there. That's all I can take from this. And this is the area where he saw on the edge the red blood was coming out. All right, so don't forget, the real red stuff was on top of this. All right, the real red stuff was on top of that. The yellow stuff was way over here, and this was in the middle. So the red stuff was over there, but it had separated. All right, see the red stuff was over here, separated, which made that oxidize, causing it to be black looking. When they, blood oxidizes, and that's what it does in your body. That's why your veins are purple, and your arteries have red blood in them. And you can see it just opened up, and that's the heart. And so think of how long this must have been sitting around for. And he just wiped his fingers across, and it's saturated with blood. Right there, saturated. There's no faking that. All right, so we're going to get deep, because all of the things I'm showing you here with Typhon and the fish in the desert and the giants and the monsters and the dragons, and we got a lot to do, because we got to talk about Mars too, and all the things that are on Mars basically are very similar to the things that are on Earth. And then Venu they just came back with, which is a heart. This is the same as this here. That's a heart, and there's tubes coming out of here. The same thing with Psyche, only this one got really close to a hot, almost cooked in some atmosphere somewhere, and partially smelted. You see how it's all turned into metals? That's what the blood does. Blood is all metals. It's all metals. And that thing will swish right next to a planet, and it turned into metal. Now, Bennu has not been molested like that. It's just drifting around in space, but it's still a heart. And these are the valves, and there's the plumbing and all that. I show this in such great detail. It's just incredible. And what we're looking at is in these chambers. This is the chambers. This is it. And Comet 67P is a hip joint, and Umau is a finger. And virtually anything that you can show me a great detail of, I'm going to tell you what, I'll be able to tell you what it is. Because they're all body parts. I have a lung here that is magnetic. It's iron, and it's a lung, and it came through space. And it still has blood in it, because it didn't get cooked up so much. Like, when I put a little water on there, and I'll put it in the microscope in the next video, we're going to get into all of this. I mean, microscope city we're going to do. I love doing that. Now, this turned into iron. You see it? That's why the magnet sticks. All right, but it didn't smelt so much that it just turned into a blob. This did. That's an iron lung from some huge creature. That's an iron lung. That's a lung, and then it turns into metal. Metals are what happens after you smelt it, and it's smelted coming through the atmosphere. Now, they don't always come straight down. Sometimes they come in with the rotation of the Earth. Sometimes they come against the rotation of the Earth. Sometimes straight down, all kinds of things. This, I'm not sure. I'm trying to figure out if it would come in with the rotation of the Earth and linger in that hot zone for a long time without getting really torn up because it came in slow with the rotation of the Earth. This is obviously quite an anomaly. But that I can guarantee you, no question whatsoever, that's a lung. And I have other shots of this. You can actually see the red artery blood. You see that? That's the same meteorite. If you look right there, now you got to look real careful, real close. Let me scooch in there. Hold on. You see that little red spot? That's one of the little arteries, or the little blood vessels that carries the blood around inside. Like this one here. It's the same stuff. Same. And this got formed a little bit coming through space or whatever. I don't know. It's pretty well smelted. Now, is there other things that I can show that indicate that there's blood in meteorites? Absolutely, there I can. And here's another one right here. You see this? This is a metal meteorite. Now, this would be basically like this one here. And if you cut it across and etched it with acid, you would see this. But you needed, this one still has a lot of pockets in it because it's not big enough to get hot enough to turn into a big ball of liquid. This one could have been a liver, I would suspect. These are the vein, and that's the artery. And all these different colors are different types of metals. And that, all your blood, like I say, consists of a bazillion different metals. And here it is right up close. You can't miss it. There's the red artery. There's artery blood, red blood. And every time you have red blood, you have the black because that's the vein blood. And all these different colors and crystallizations are because it melted and they're all boiling and bubbling and then they all find each other and they create these crystalline patterns inside the metal. Okay, like I said, this is over the top crazy. I don't disagree with that, but all of these things were written about, and here they are looking down from Google Earth. You see right there. There's no question you can see this. If I had internet right now, I'd be going down in here, which I've done 100 times, more than 100 times, and I cannot get anybody to respond that is talking about the geology of the earth and all this business and all how these formations occurred, and they call them flat irons, which are the dragon scales. It's absolutely incredible. See, I can't get to the internet. Now, why? I don't know. This is going on a week now, so that's why I haven't been posting, but I'm hoping tomorrow I'm supposed to have somebody that apparently is going to be able to fix this. I am hoping. But this is what we got. That's a dragon. And he was written about in Apollodorus 1.6.3. Look it up, Apollodorus 1.6.3. They said his head often brushed the stars. If he stood up, he would be about 3 times higher. I believe I figured something out. I think it was 3 times higher than the space station, something like that. Which is, you know, we got a lot to learn. We got a lot to learn. Now, speaking of that, I'm done for today. I'm sorry I took up so much of your time. I am going to have to go through all this with a fine-tooth comb, one thing after another, until we get to the end of all of these, and I can make all my statements, and then you can question me how I could come to arrive at this conclusion. And I will try to support my claims. All right, so a lot of this is going to be microscope, a lot of it's going to be chemistry, a lot of it is going to be mainstream, and then I comment against what they say. But literally, virtually 100% is going to be based in material evidence. There's no big fluffy ideas. Velikovsky went and got all of the documentation from everywhere in the world, what every culture said about this particular time they created the Mudfossils. And even Caesar, Augustus, he died in a great flood. There's his feathers. And if anybody can tell me what kind of a bird this is, has a feather pattern, one big lump like that, and it's not a wood duck, I don't think. It doesn't have the same, anyway. This was, I believe, 3,500 years ago. And here he is flat on this side because he died in a great flood. And there's his neck, and you can see the pattern of his neck, and there's his artery, and there's the vein over on this side. You have to know how to look for this stuff. You have to know what you're doing. It's not hard. There's a little nose hole. All right, now, I have so much of this stuff, it's stunning that it has been dismissed for so long. And the kids are not being well served. That's just a fact. There's nothing you can say about that. It's a fact. So we're going to get into the next video, and it's going to be extremely detailed how I claim all of this stuff happened, what the chemistry is, the chronology of it, the ages, all of these different things from the Egyptians coming down. There's a certain point, there's nothing you can say other than what was the original text. And I go to Apollodorus, and you look at Apollodorus, and it will blow your mind. It talks about Gaia giving birth to the 50-headed 100-handers, Cyclopses, giants, Hercules, all those things it talks about. And I'm telling you, it talks about this right here. And it happened. And Zeus was the one that had the daughter. Well, you know what? I'm going to leave it at this for today. I just keep fluttering on here. I'm sorry. We're going to go much, much, much deeper, because we have to. We have to go to everything. We have to go to the texts. We have to go to the chemistry. We have to go to the statements of these early philosophers. They studied these things, and they were much closer to the source. And we have become enlightened into darkness. All right, I love you all. Let's see, stick around. Hopefully I will be able to get this up online soon. All right, I love you all. Goodbye.